Hi everyone. Good morning guys. Very good morning all of you. Shruti, Tajamul, Nagalakshmi, Anjali. Good morning everyone. Only you people joined. Hare yaar. Why daily that number of people coming to the class are decreasing day by day? Right. Okay. So here we'll be continuing our discussions on which one? This Q concepts and PYQs and CTQs of RCC and PSC. Materials and specifications part only we will be discussing still. Right, part 6 in this materials and the specifications we'll be discussing now, you can say, right? So now tell me, anyone having any doubts in our previous discussions, all of you? Anyone having any doubts in our previous discussions, all of you? No doubts? Okay. Right, if no doubts, we'll proceed further then. Right. So all of you, welcome to Unacademy. Let's crack it, right? Everyone is ready to crack? Everyone is ready to crack or not? Everyone get ready to crack, all of you? Right. So here, this is my profile. If you are following my profile, okay, share my profile to all your friends to follow, right? So are you sharing my profile to anyone or not sharing? Did you share to anyone, or till now, sir, why we did not share? You shared or you did not share to anyone? Did you share to anyone or not? Not shared? Okay, very good, right? So here, shared, very good, right? Yeah, Omar Prasad, good morning, right? So this is the referral code. RP Civil is the referral code you have to use always, right? Whenever you are subscribing to which one, this any subscriptions, right, in Unacademy. So now you know these are all the subjects I'll be taking in Unacademy Plus platform, right? These are all which one, toppers from SSC JE and state AE JE. So from the previous years, right? From the previous year, right? You wanted to have your name and photo here next time, na? Then what you need to do? You have to work hard and you have to work smart, right? Always you have to work, and all the ways possible you have to work, and you have to get this, you can say, all of you. Okay. So now coming to this. So SSC JE State AE course, a new English batch is starting, all of you, right? That a new English batch will be starting, everyone. It is now in English, right? Previously it was in English, now it is in English, right? This English, whenever it is English is there, means it is fully in English only, right? There is no Hindi used, right? So those who are willing to attend the classes only in English, it is useful for all of you, right? So these are all the features of this subscription you are taking, right? Now Samarth batch, right? So Samarth batch for which one? This SSC JE State AE examinations will be starting in English. So here these are the faculty, right? KP sir, myself, and Amit Jarala sir. So Amit sir will be coming actually on our request only, because we want syllabus to be completed for you early now. Listen, because those who are subscribed already now. So for completing them, so one of the technical subject Amit sir will be taking, so that I can cover one more subject, right? Yes, na? So that many subjects will be covered up, na? That is what. So Amit sir will be taking RCC. So suppose if you are attending this RCC in the special classes, no need to attend that RCC in the place class, or if you want you can attend, no problem, there is no issue. But depending upon your time situation available, right? Depending upon the time available, you decide, okay, for your examination. These are the features of this course, you can say. And now, so Amit sir will be taking RCC, and these are all the subjects will be taken by myself, and these remaining subjects are taken by KP sir, right? These are the major changes, you know. Airport Authority of India. How many of you applied for Airport Authority of India, everyone? Have you applied or not? All of you. Everyone applied for this Airport Authority of India exams or not applied? Everyone. No, if not applied, you start applying, right? I think, I don't know whether time is there or not. You just check and apply, right? So don't miss out, right? Don't miss out, right? After the time is over, don't think about it, right? Right, you have to be careful, right? You have to be careful, right? So any graduate can apply. Yes, any graduate can apply. You can just apply, no? Listen, no. What is there in that? Yes, non-technical syllabus is there everywhere, na? Tell me where it is not there. Tell me. In all your examinations, non-technical syllabus is there, na? In your state examinations, SSC JE examinations, everywhere that non-technical syllabus is there, na? So are you doing any separate preparation? or same preparation only you have to do? You will be doing any separate preparation, or same preparation itself will be sufficient enough, right? So no separate preparation na. So because so you will be exposed to more kind of examinations na. So just only that exam fees you may be having lost, but what is advantage? Yeah, Katila Jagan, good morning. So but what is advantage you can say? The main advantage is that, but what is the main advantage you can say? The main advantage is that you will get experience of examination, right? That is what the advantage you can say, right? You will get the experience of which one? This experience of examination you will be getting, right? That is better, right? Yes. State AE will be having non-technical. So no, JE may be having technical, okay, let it be, but state AE will be having non-technical, definitely. And some of this state JE also will be having this non-technical, right? It is depending upon the type of this state, okay? Omar, you have to be careful, right? Yeah, in Tamil Nadu for JE also it is there, right? Yeah, Kavya, namaste, right? Everyone, is it clear? So you have to go for, right? You have to be careful, right? According to the examination you are writing, you have to do your preparation, everyone, okay? You have to be careful. Right, now coming to this. So this is one batch was there, right? Which batch? Recorded batch was there for this. If you wanted to go for, you can enroll for this, you can say, right? Now these are the plus courses we are doing, right? Sorry, these are the plus courses we are doing at present, right? What are these plus courses we are doing? If you just observe, we are doing, right? Complete course on this surveying we are doing now, right? At 5:30 p.m. to 7:30 p.m. every day, and this is a free course on this quick concepts and PYQs and CTQs, right? Concept through questions also, some concepts will discuss in case of this RCC and which one? That pre-stressed concrete, okay? Right, yeah, just we logs, Vinay, Rahul, Ankit, Akash, good morning. RCC का भी all state PYQ session solve कर दीजिए sir, please. Yeah, all state PSC, okay, first we'll complete it. We'll complete these concepts now. After completing the concept, we are discussing the concepts as well as PYQs now. As Akash Gupta, we are doing which one? This we are doing the PYQs as well as concepts, right? Both we are doing in this series, okay? So no problem, right? Concepts will be covered extra, plus PYQs also will be covered in this, right? Other than PYQs also will be covered, right? Okay, so you need not worry much. Now, so whenever you are having this concrete, right? So yesterday what we have discussed about this concrete, if you just observe that grade, that m, that x, some number is given. So what is that x representing? That x is representing that characteristic compressive strength corresponding to how many days, everyone? That 28 days na. And what is that m representing? That m is representing that mix, you can say, right? For this mix proportion, right? What is the meaning of this mix proportion? So 1:2:3, 1:3:4, right? Like that will be mixing in any proportion, na? That is a mixed proportion, you can say, right? In that mixed proportion, we'll be having this, right? So now that tensile strength of this concrete, what is that symbol we have given? FCR equal to that 0.7 root FCK, right? And here coming to this tensile strength, right? You will be having which one? This various tensile strengths will be having. What are the various tensile strengths you will be having? Tell me all of you. So tomorrow will be the mostly last class on this. What are the various tensile strengths you will be having? Tell me all of you. What are the various tensile strengths you will be having? And before we enter into this tensile strength of this concrete, okay, whatever it may be, right? This is split tensile strength you are having now. So the one is your bending strength, other one is your split tensile strength, right? Like that we'll be having the different types of this tensile strengths present, or not everyone? Different types of which one? This tensile strengths are present, you can say, right? Yes, no? Different types of this tensile strengths are present, right? And before we enter into this part, right? Before we enter into this part now, so what we'll try to do is, yeah, okay. What we'll try to do is, right? We'll try to get which one? Some more information, right? We'll try to write which one? This is some more information on this compressive strength, right? Then we'll be going on to which one? This tensile strength, right? So now, characteristic strength of this concrete, right? What is the characteristic strength of this characteristic cube strength, if you just observe? So there are various compressive strengths you are having, right? These are very, very important, you observe. So compressive strength of a concrete, right? Rakesh, good morning. In this compressive strength of this concrete, so what is that first and foremost compressive strength, everyone? Compressive strength of a cube, right? What is the meaning of this compressive strength of a cube, all of you? इसका meaning क्या है? What is the meaning of this compressive strength of a cube, everyone? What is the meaning of this compressive strength of this cube? Just whenever you are applying this compression, right? What is it you can say? Just whenever you are applying this compression, compressive strength of this cube means, so what is it you can say? At 28 days. On which cube? At 28 days of which cube? 150 millimeter cube, na? But can we take this value as a characteristic compressive strength of cube, or we cannot take this value as it is as a characteristic compressive strength of cube? We cannot take this value as it is as a compressive strength of this characteristic compressive strength of this cube, na? So for a mixed proportion, whenever you are testing some number of cubes, 95% of this test results are more than which value, and only 5% of this test results are below which value, that value will be taken as your characteristic compressive strength of cube, na? Everyone. So the compressive strength of this cube is different, as well as the characteristic compressive strength of cube is different. Both are same or both are different, you can say now. Both are same or both are different, all of you? Characteristic compressive strength of cube. So what is the symbol we are giving for this? That is your FCK is the symbol we are giving, na? FCK means characteristic compressive strength of cube, right? So this is the strength. What happens? This is the strength below only, below which how many are present, you can say? Strength below which how many test results will fall? Only 5% test results will fall, na? So if you are telling one value as a characteristic compressive strength means below that value, right? Below that value, how many percentage of vehicles will be there? How many percentage of these cubes will be having? Only 5%, right? Below which only 5% test results fall. Now, above which, what is that you can say? Strength above which, how much? 95% test results will fall, na? 95% test results will fall or not? Above which 95% test results will fall, right? So that is your characteristic compressive strength of a cube. Of which one? This is at which days? This is at this 28 days. Of which cubes? Of 150 millimeter cubes, na? Of 150 millimeter cube, right? Of 150 millimeter cube, you can say, if you just have, right? Is that clear, everyone, now? Right? Is it clear, all of you? Is it clear, all of you? Right. So now if you just consider it, so once it is clear, noted, once noted, tell me. Those who are noting down, just tell me, all of you. I'll try to move forward. Note and tell me. %95 test results. Fall means what? What is the meaning of this fall? Fall is nothing but your, it is not below, it is not above, right? It is just under this category, right? What does it mean is, what is the meaning of under this category, right? Under this category, right? So fall means that is also, you can apply fall also, okay? So now to avoid the confusion, so below which only 5% test results will be there. So above which 95% test results will be there, okay? Below that 5% test results and above that 95% test results. Yes, na? Noted, everyone? It's done, all of you? Right. Shall I move forward? Shall I move forward? Right. I'll be moving forward. So what is that? This is your second characteristic compressive strength of this cube, right? But here what is that? You can say characteristic strength of concrete. So we are mentioning for, okay, for characteristic strength, compressive strength, right? Characteristic, which one? This is a compressive strength of what? Cylinder. Characteristic compressive strength of cylinder, right? So tell me, what is the characteristic compressive strength of this cylinder, all of you, everyone? What is the characteristic compressive strength of cylinder, everyone? Characteristic compressive strength of cylinder is nothing but, you are right, what is it you can say? So here in India we are using the cube as a reference, but in US what is the member they are using? If you just observe, they are using this cylinder now. Can anybody tell me, right, what are the dimensions of this cylinder? If you just observe, this is 150 millimeter is that diameter, and what is that height, you can say? That is your 300 millimeter height na. So no, 150 millimeter diameter and 300 millimeter height, or not? Yes, 300 millimeter height, you can say, right? So now tell me, which one is more appropriate? If you just observe, compare, cube will give more appropriate correct results, or uh, sorry, cylinder will give more appropriate results, right? Cylinder will give more appropriate results, right? Cylinder, you have to be careful, right? Cylinder will give which one? This is more appropriate nearby results, right? More appropriate, which one? This is nearby results. Why? If you just observe, right, why? What is the reason, everyone? Tell me why. What is the reason? So whenever you are testing this cylinder na, whenever you are testing this cylinder, right, so uniaxial compression only we have to apply na, direct compression or bending compression, it is direct compression only na. Now whenever you are applying this load, if you just observe, right, what happens if that load is applied? Now tell me, these end portions, right, at the bottom support is there, at the top load is applied. Now tell me, these end portions are these under the effect of this plates na. These end portions are under the effect of this, which one? These end portions are under the effect of this, which one, you can say? Effect of these end plates or these loading plates na, everyone. Whenever these end portions are under this effect of this, which one? Effect of these end portions are under the effect of, which one, you can say? Effect of these end plates. So they will not be giving correct results, right? Which portion will be giving correct results, you can say? Now this portion will be, there is a lot of portion available, that central portion, which is not affected by these end plates now. So this is central portion is affected by the end plates, or central portion is not affected by the end plates? Tell me. Central portion is affected by the end plates, or see. Now whenever these plates are there, these plates will cause more effect. They will hold the cylinder up to the full length, or they may be holding only the end nearby portions. They may be holding only the end nearby portions na. They may not be holding the full length, right? Because the dimension, the length dimension is very much higher na. The length dimension is very much higher. Now the central portion is affected by these end plates, or central portion is not affected by the end plates? Tell me. The central portion is affected by the end plates, or central portion is not affected by the end plates, all of you? The central portion is not affected by the end plates, right? So whenever that central portion is not affected by the end plates, it will be giving correct results na, yes or no? Nearby correct results na. So at least some portion is giving its own behavior, right? Not affected by these end plates. But if you consider this 150 wala cube, what happens? Whenever you are having this 150 wala cube na, 150 millimeter cube, if you just observe, so entire cube is under the influence of these end plates na, because the dimensions are lesser. So here what happens, you can say, so this end plate may affect this portion, and this end plate may affect this portion, right? Entire cube is under the effect na. So is it telling its own behavior, or it is telling the affected behavior? So it is giving the not 100% true behavior na. So is there any possibility of getting that a true behavior or a true strength? It is not that a true behavior na, in this left side. But right side also, this cylinder also 100% true behavior is possible, or at least some few behavior is possible. 100% true behavior is possible, or at least some true behavior. At least some true behavior is possible na? So which one is more appropriate? Tell me. More appropriate nearby results, tell me. So some true behavior, right? Some true behavior. At which one? That is at center, na? Mainly at the center. Right now, tell me, cylinder will give the correct results nearby, or they will be representing the exact behavior, or cube will be representing the exact behavior of this concrete if you just observe now. Is that point clear, everyone? So this point can be asked in the examinations, right? Interviews and those things. Is not? Is that clear? Is that clear? So that is unaffected by this friction, na? So this portion is what? Unaffected by this plate friction, na? Unaffected by which one? Plate friction. So plate friction means end plate friction, na? But here this portion is affected, this portion is affected, right? Here fully affected, na? This is entire portion is affected. Here only this portion is affected, and here this portion is affected, right? Like that. Is that clear, everyone? Now why cylinder is representing that? Why cylinder is representing that why cylinder is representing that little true behavior compared to your cube? Got it, all of you? Everyone understood? Right? So once clear noted and once noted, tell me all of you. This point is clear or not, all of you? Okay. Clear, everyone, these points? Noted? Everyone noted? Others also? Right? Now coming to the fourth one. So now tell me which one we have to consider for the real members of this concrete. Whenever it is a real member, what is it we have to consider if you just observe? Characteristic strength. Okay. So tell me, is there any relation between this cube strength and this concrete strength at this 28 days? 2 years back only noted. Okay. So F cylinder, right? F cylinder will be approximately equal to how much you can say? 0.8 times this F cube, na? Right? This is also very important, right? They will be asking the examination sometimes, right? So cylindrical strength will be how much you can say? Cylinder strength will be how much you can say? Approximately 0.8 times which one? This is a cube strength, right? Approximately 0.8 times which one? This is a cube strength if you just observe, right? Is it clear? Cylinder strength will be approximately 0.8 times this cube strength, all of you, right? Is it clear, all of you? Everyone? Right? And so whatever we are getting that FCK, that FCK will be representing the true behavior of this concrete, or we have to reduce it? Tell me. That FCK will be giving the true behavior of concrete, or we have to reduce it? Definitely. We have to reduce it definitely, na? Yes or no? We have to reduce it definitely, right? We have to reduce it definitely, right? So now tell me, what is that fourth one? So the characteristic strength of concrete. So now in general, whenever you are considering the concrete, that concrete, will it have only that 150 millimeter and this this cylindrical shape it will be having, this cube shape it will be having, obviously, or it may be having different shapes and different dimensions also. It may be having different shapes and this different dimensions also, no? Yes or no? Then in that case, in general for concrete, can we take this F cylinder, or can we take this FCK as it is, or we have to reduce it? Characteristic compressive strength. Characteristic compressive strength of concrete, right? What is the meaning of this concrete? Of concrete in general, right? Concrete, which one? This in general. In general का मतलब क्या है? What is the meaning of this in general? This is applicable for any shape and size, na? So for any shape and for any size, right? For any shape and this any size you are applying, right? So for any shape and any size if you are applying, right? What is that you can say if you just observe, everyone? For any shape and this any size if you are applying, right? What is that you can say? So that that concrete, F concrete will be taken is equal to which one? That is 2 by 3 times that FCK cube. FCK means it is made with the cube only, no? Or 0.67 times this FCK, or you can also write it as this FCK divided by this 1.5. So what is this factor considering which one? This is a factor considering which one you can say? This is a factor considering what? Size and shape effect, na? Factor considering that size and shape effect, right? Size and this is shape effect, right? So here if you just observe which one is having that more size, cylinder is having the more size or cube is having the more size, everyone tell me. Cylinder is having the more size or cube is having the more size? Cylinder is having the more size than the cube, na? And now tell me whose strength is higher? Cylinder strength is higher or cube strength is higher? Cube strength is higher and cylinder strength is lesser, na? So what you can understand from this, as the sizes increases, slenderness ratio increases. When slenderness ratio increases, strength will be decreasing. So we have to keep the cube strength as it is, or we have to decrease it? We have to decrease it, na? And shape consideration also, and every other effect also, it will be taken as 0.67 FCK, right? Now tell me, if at all it is a strength of steel, we are taking it as Fi directly. Strength of steel, we are taking Fi directly. Why? Uncertainty is lesser as it is. But strength of concrete means FCK as it is can we take, or 0.67 FCK we have to take it, right? 0.67 FCK we have to take it, na? Because it is due to which one? This uncertainty, na? Due to which one? This uncertainty, na? What is the meaning of this uncertainty? It will not show the same strength in all conditions, right? When shape changes, strength changes, size changes, strength changes. So uncertainty will be present more in the concrete or not? So that is why FCK should be taken as it is as the compressive strength of this concrete, or FCK by this 1.5 should be taken better. Which one is better to take care of the uncertainty? To take care of this uncertainty. I have written due to uncertainty it is written. Whatever I have written only I am explaining, right? This is a factor considering the size and shape effect. This is a factor considering the size and shape effect, right? And why it is lesser value? Why we are considering this factor? This is due to that uncertainty, right? Due to uncertainty in the concrete strength. Already written, na? Listen. Right. You wanted to write word by word? Don't see. Make a habit of writing in short and understanding in short. Okay. If you write word by word, sentence by sentence, there is no use, right? It's just like mugging up only, right? Okay. Just within short sentence you have to understand everything. That is better. Okay, you try to make a habit of that one. That will help you a lot. Okay, note it and tell me everyone. Note it and tell me all of you. Noted, tell me. Noted? Right. So now shall we? Yes, cylinder strength will be lesser. That is what you have mentioned, na? Cylinder strength will be 80% of this cube strength only. Already we have mentioned this, na? Cylinder strength is 80% of this cube strength only. For which one? For same mix, na? For same mix. It will give which one? It will give more nearby results. That is what? What more results? More appropriate, more nearby actual results. So means the cube will be overestimating the strength of this concrete. Now, if concrete is having that 20 MPa, that cube will say that hey, your concrete is having 30 MPa. That is wrong, overestimating. Cylinder will give which one? This it is saying that. So if your cube strength originally is 20 MPa, so cube will say that hey, your concrete is having 30 MPa. Cylinder will say that your concrete is having which one? This is 24 MPa, right? Like that. But actual strength is 20 MPa. Even cylinder also will not give exact 100% answer. But appropriately, which one is near? 20 is the full strength. 20 is the actual strength. But cube will be showing 30. Cylinder will be showing 24. Which one is nearby? More appropriately nearby? Cylinder strength is appropriately nearby, nearby 20, because 20 is actual one. So cube is overestimating as well as the cylinder is also overestimating the strength. Shruti, is clear? But which one is giving nearby value? Cylinder is giving nearby value, right? It is more appropriate, not more value. Cylinder will give more appropriate nearby results, not more value. You have to be careful, right? More appropriate, right? It is not more value. You have to be careful. Okay. More appropriate value. Okay, that is the meaning of it. More appropriate means more nearby. It does not mean that value is higher. Okay. Now, So we'll go for which one? This is a tensile strength if you just observe. Okay, tensile strength, right? So now can we have this a direct tensile strength if you just observe? Is it possible to measure this using this direct tension? Or before we enter into this tensile strength, right, what is that we'll see is, we'll just look at one thing. So this is stress strain curve for this concrete, we'll see, right? So we did not discuss about this stress strain curve for concrete now. So this is how the stress strain curve for this concrete will come into picture, right? This is your strain, that is your which one? This is stress, you can say, right? Yes, now. So now what happens if you just observe? Whenever it is your M20 concrete, just for an example, right, I am showing different grades, right? This is, let us say, M20 concrete, it comes like this. This is M20 concrete, right? So for M30 concrete, it will come above or it will come below? M30 concrete, right? Okay, this is your which one? This M50, let us say, just for an example, right? That is M50, let us say, just for an example, right? And we'll be having which one? This M30 in between, it will come now. This is your which one? This M30, you can say, right? So like that. So this is your 50 MPa. So that is your 50 MPa, and this is your which one? This is 30 MPa. It will be showing highest value, and this will be showing which one? This is 20 MPa, right? That is your stress strain curve, right? Is now. So now if you just observe, right, what is happening here everywhere? So wherever they are showing the highest strength, right, what happens, everyone? So wherever it is showing the highest strength, it will be corresponding to which one? This is 0.002. What happened here? Zero point 0.002, right? 0.002 means, can we say 0.2 percentage na? 0.2 percentage na? Yes or no? 0.2 percentage, right? So 0.2 percentage if you just observe, right? Is now. So now what is that, you can say? So but it will be idealized as which one? We will be taking as it is for the designs, or it will be idealized? It will be idealized. So we don't take as it is, right? It will be idealized. Idealized means what? Modified na? Idealized means it will be modified, you can say, right? How it will be modified, everyone, if you just observe? How it will be modified, everyone, if you just observe? It will be modified in this manner na? It will be modified in this manner, you can say, that is your stress versus strain, right? So how it comes? So first we'll be assuming it as this parabolic variation only, and after that we'll be making it as a straight, right? We'll be making it as which one? This is straight, right? Do you remember that now? Now are you coming across this one? So stress block parameters, it will be like this only, no? Yes or no? Those who recollect stress block. So from 0 to 0.002 strain, we'll be considering it as which one? This is your FCK, we'll consider now. This is your FCK, actually we have to use, right? So this is FCK, we have to use it, right? FCK we have to use it, but FCK we are using our 0.67 FCK we have to consider. 0.67 FCK we have to consider, okay? And this strain will be taken as 0.0035, okay? 0.0035, we have to take it like this, right? So now tell me, so this is stress strain curve for this concrete is linear, or stress strain curve for this concrete is non-linear? To tell me, the stress strain curve is for concrete is linear, or it is absolutely non-linear, everyone? It is absolutely non-linear na, but we are assuming like this, we are modifying it like this, is na, right? So now tell me that maximum stress, so maximum stress or this strength, maximum stress it can take is nothing but your strength only, no? That maximum stress or this strength corresponding to which strain, you can say? That should be taken corresponding to this 0.002 strain only, no? Why? In the steel also, reinforcement also, right? What is the maximum strain we are considering at the failure? 0.002 or 2% strain, that itself will be taken as your proof stress or this yield stress na, corresponding to this 0.2% strain only na, corresponding to this 0.2% strain only we are considering, or not, everyone? Corresponding to this 0.2% strain only, if you just observe, right? Is it clear, everyone? Is na, corresponding to this 0.2% strain only, you can say, is na. So here also we are ensuring the strain compatibility, or we should not ensure strain compatibility. I'll tell you that. Let us complete point 002. We are ensuring, we have to ensure the strain compatibility, or we should not ensure, we have to ensure the strain compatibility na? So when we are ensuring the strain compatibility means, what is that you can say, 0.002 strain is the failure strain of your steel. So 0.002 strain also will be the failure strain of your concrete, you have to consider, right? Right, because of this strain compatibility only, what happens, you can say, it reinforcement and concrete can be used together, right, instead of aluminum, instead of some other thing, right, like that. And okay, so here what is that maximum stress or this strength will be corresponding to which one? This is 0.002 strain, right, 0.002 strain, right. So now tell me, as now tell me ultimate strain, right. So that is ultimate strain lies between which one? But even though you are reaching this strain, it is subjected to breaking, no, so it is taking further some other strain na? So this ultimate strain will be varying from which one? 0.004 to which one? 0.006, okay, 0.004 to this is 0.006, right. And considered for design is which one? For bending, right, used ultimate strain, right. So for bending compression, right, what is it we are using, everyone, if you just observe? Generally for this bending compression, right, what is it you can say, this epsilon ultimate will be how much? 0.0035, right. So now you understood what is the 0.0035, Shruti? So it is a bending compressive strain, right, bending compressive strain, you have to be careful, right, bending compressive strain, right. There will be one question from this also, right, means indirectly why it is like that, okay. So bending compressive, and here what is that you can say, for a direct compression, right, whenever it is for this direct compression, whenever it is for this direct compression, right, what is that ultimate strain, you can say 0. What? 003 only, right, 0.003 only, you can say, right. In your compression members, right, columns you will use this value, right, columns you will use this value, right. And in case of this tension, any tension, whatever it is, ultimate strain will be how much? What is that ultimate strain? 0.0001, right, 1/10 not 0.0001 to which one? This is 0.0003, okay, like that you are having it. It is not 00, it is 000. Is it clear now? Ultimate stress values, ultimate strain values under various conditions. Now tell me what you can understand from this. It will be taking more strains in, it is capable of resisting more strains in the bending compression compared to this direct compression, if you just observe. So direct compression, it can take the strains up to 0.003 only, but in the bending compression it can take the strains up to 0.035, right. Means what does it mean? It means that it can resist more deformations in bending compression or direct compression. That means it can resist more deformations in the bending compression than the direct compression, right. Why? Because whenever it is a direct compression, load is applied directly and it is crushing, so direct effect will be there. But bending compression means load is applied in the vertical manner, but the bending is offered in the horizontal manner, right. So that bending compression will be created in an indirect manner na? So direct effect will not be there, so indirect effect will be lesser, or sorry, indirect effect will be lesser or direct effect will be lesser, tell me. Indirect effect of this load will be lesser na? So more capacity, right, indirect effect will be lesser, so indirect strength will be more, okay, got it everyone? Why that bending compression in the bending compression concrete will take more strength, more load or more strain than the direct compression, everyone understood? Everyone understood this, right? So here what happens now? So whenever you are applying this vertical load on the beam, it will be bending like this, and the bottom layers compression will occur. Now tell me, the load is directly creating the compression in this, or indirectly it is creating? The load applied, vertical load applied, will be creating the compression effect at the bottom indirectly na? It is creating indirectly na? Yes or no? Is it applied, Gopi? Is it applied like this and creating compression in this manner? No na? It is applied in some other manner and compression is created like this. If you are applying the loads directly, like if you are applying the loads directly like this and creating compression, that is direct. But you are applying load somewhere else and compression is created like this. So means that in case of this bending a compression, the compression effect will be direct or compression effect will be indirect, you can say. The compression effect will be indirect. Now, will it create more effect as that of that, or it will create less effect as that of direct compression, you can say. When you are applying a direct load and creating compression, it will be more effective, or when you are creating indirect compression, it is more effective. Direct compression will be more effective. So no, direct compression will be more effective and indirect compression will be less effective. Is it no? Is it clear? Is it clear? Now let me go. Direct compression is more effective and indirect compression is less effective, right? Means the damage caused by direct compression is more and the damage caused by indirect compression is less, obviously. Ankit, good morning. Damage caused by this direct compression is more and the damage caused by this indirect compression is less, obviously, or not everyone? Yes, less, absolutely, right? Isn't it? So therefore what we need to do, therefore indirect compression effect is lesser, damage is also lesser, means it can take more strains further or not? It can take more strains in the indirect compression, right? Got it? Now understood? Clear, Nagalakshmi? Right. So now we'll be going for this, right? Now we'll be, so tensile tension, it will take almost 1/10 of this compressive strain. Why? Because the tensile strength will be almost 1/10 of this compressive strength, you can say, right? Now coming to this tensile strength, we'll discuss few points. Anki, good morning. Tensile strength, what we'll do, we'll discuss few points, right? So here those who are not in our telegram group, free classes group, okay, especially this is free classes group, you can just join this. One second, I'll give you the link. One second, all of you. Where is that? One second, guys. Right. So those who are not in our free classes group, those who are already in place, no need to join because for plus students a separate group is there. Yeah. Those who are only for free classes, you can just join this group. You'll be getting the regular updates of free classes in this. Okay. Right. So tensile strength, right? Whenever you are going for the tensile strength, so what is it you can say? First one, a direct tension test. Is it practically possible to have this direct tension test, or it is not possible to have this direct tension test, everyone? Direct tension test is practically possible to have or not practically possible to have for a non-homogeneous material? This concrete is a homogeneous material or non-homogeneous, all of you? Concrete is absolutely a non-homogeneous material. So whenever it is a non-homogeneous material, it practically it is possible or practically it is not possible? Even though if it is possible, it is very easy or it is very difficult, you can say. Even though it is possible, it is very easy or it is very difficult to conduct this test. It is very difficult to conduct this test. So what is it you can say? Practically very difficult to conduct on concrete. Why? It is because of its non-homogeneity. Yes or no? Why? Since a non-homogeneous material, and whenever it is a non-homogeneous material, so the behavior will be same everywhere, or the behavior will not be same everywhere. The behavior will not be same everywhere. It is different at different locations, right? Is not like that. Second one, what is it you are having? Flexure test. So flexure test, right? Flexure test, right? What is it? Flexure test, right? Do you remember this flexure test, all of you? Here, this is your flexure test, na? Yes, no? This is your flexure test we are conducting, na? This is your flexure test. This is your which one? This is split cylinder test, right? Split cylinder test. So these two we are conducting, right? For tension, yes, no? This is flexure test, right? Have you observed? Here support is there, here support is there, and here the by means of these two we are applying the load, is or no? So have you observed? So why we are applying, right, a pure bending condition we have to create, is or no? To create this pure bending condition, you can say, all of you, right? So whenever you are applying this, how you will be applying this? If you just observe, it will be applying in this manner. So let us say this is your B, is no? This is your D, and what is this? Right, here we are applying the load, that load P we are applying here, and here also that load P we are applying here, right? And here you are having this supports. Now it is like a simply supported beam only or not, everyone? It is like a simply supported or it is like a cantilever? It is like a simply supported only, no? Have you observed this? This is like a simply supported only, no? This flexure test will be conducting. It's like a simply supported only, no? At this end support is there, at this end support is there, you are applying the loads in between, right? Simply supported concrete beam only, no? This is concrete, right? So yes, now is it clear? Now, so at which distances will be applying these loads? If you just observe, at which distances will be applying these loads? If you just observe, right, L by 3, L by 3, L by 3, na? Yes or no? So here, so total length is L, you can say, right? Out of this L, right, what happens, you can say? This is L by 3 and this is L by 3 and this is also which one? This is L by 3, right? Yes, na? Like that you will be having, yes, na? So now, do you remember what is the bending moment diagram you are getting, all of you? The bending moment diagram, do you remember, all of you? The bending moment diagram will be like this, na? SFD, BMD, if you just remember, all of you. So now tell me, here bending moment will be there, and what is the shear force diagram, you can say? The shear force diagram will be like this, na, everyone, right? So at the central portion, right, what will happen, right? No shear force at the central portion, right, that no shear force will be there, na? At central portion, no shear force will be there, and the bending moment is constant, right? Now can we say it is a pure bending condition? The central one is pure, having pure bending condition. Only bending moment is there, shear force is not there, and that too bending moment is constant. So can we call it as a pure bending condition, everyone? Why we are applying load like this only? Why can't we apply a single load? If you apply a single load, pure bending condition may not be created, right? To create the pure bending condition, we are using it, right? Good morning. Clear, everyone? Why this kind of load is applied, all of you? Flexure test. Clear, all of you? Right? Okay, once it is clear, noted. Once this is noted, tell me, we'll try to move on to the next. Pure bending means only bending moment will be there, and that too it is a constant without any shear force and without any axial force, without any twisting moment, without any other forces. Okay, that is pure bending condition. So now at the center, if you just observe central portion, that is bending moment is there and it is constant maximum. At the central portion, what is the shear force? That shear force will be 0 na, at the center. Na, this is SFD, this is your BMD. Okay, got it? So now the central portion is having that pure bending behavior or not? Now the central portion is having that pure bending behavior, na? Right. Okay, clear, everyone? Once it is clear, note down. Once noted, tell me, all of you. I'll move on to the next. Shall I move on to the next? Shall I? So direct tension test and a flexure test. So now here, so what is that we are doing? If you just observe, what is that we are doing? If you just observe here, how can you calculate this? M by I will be equal to which one? This F by Y will be equal to that E by R you are having, na? So if you are using these two, right, what is that M, maximum bending moment? P into that L by 3 is a maximum bending moment. Divided by this, what is that I? Moment of inertia. B into that small dq by this is, sorry, B into dq by this 12, na? B into the dq by this 12 equal to what is the F? FCR, right? Because that tension will create that cracking or not? Definitely. Yes, divided by this Y is nothing but your neutral axis to the extreme fiber distance, right? Y by D by 2. So this is your neutral axis, na? Neutral axis to the extreme fiber distance is how much, you can say? That is D by 2 to the top compression. This is D by 2 to the bottom tension, right? We are interested in tension, na? So then you will be getting this FCR from here or not? We will be getting FCR from here or not? Yes, we will be getting FCR from here, right? But IS 456 gives, right? But IS 456 gives, what is that FCR value? That IS 456 gives that FCR is equal to that 0.7 root FCK, na? So yesterday also I have mentioned that that is your bending tensile strength only. No, what I have mentioned everyone, that is a bending tensile strength only, or this rupture strength only we have mentioned. Na? Bending tensile strength only we have mentioned, if you just observe, right? Isn't it? So instead of this value, IS 486 is giving that value, right? So this is MPa. This FCK you have to substitute in this MPa, right? Now tell me, it is a theoretical formula, it is an empirical formula. It is an empirical formula, na? Isn't it? It is an empirical formula, you can say, right? So clear everyone? Clear everyone? Right? Clear of your bending tension. So IS 456 is giving that a cracking strength or this rupture strength. It is corresponding to this direct tension, or it is corresponding to this bending tension, or it is corresponding to this split tensile split tension. It is corresponding to this bending tension. It is corresponding to this bending tension, right? This kind of question also may be asked, right? So the cracking strength or this rupture strength given by this IS 456 2000 FCR equal to 0.7 root FCK is corresponding to which of the following tension? Option A, direct tension. Option B, bending tension. Option C, split tension. Option D, none of the above. Which one is the correct answer? Which one is the correct answer in that case? Option B, bending tension will be the correct answer. Na? Yes or no? You have to be careful, right? Noted? So this one is clear, all of you? So this formula which is given, which is given flexural strength only. No, it is flexural strength. It is already written, right? Flexural strength in tension, tensile strength. Under this tensile strength, flexural strength, it is given. Got it? Clear everyone? Now shall I move to the next? Next, what is that you can say split tensile strength? Na? Split tensile strength we are getting by split tensile test, right? Split tensile test, right? So what is that we are having? If you just observe already this diagram, you know what is this we are applying, right? We are applying a load P onto this, and this is the length of this member L, and this is the diameter D. Na? Yes or no? This is the diameter D. So then how to apply? So you apply this load, and once it is subjected to this cracking, na, right? It will be subjected to cracking. Na? So whenever you are applying a compression, right? How you are applying? You are applying compression in the vertical manner. You are applying a compression in the vertical manner. Because of this compression in the vertical manner, it is splitting in the horizontal manner. It is splitting into two pieces in the horizontal manner. So generally splitting will occur because of this tension only. Na? So we are assuming that even though we are applying a compression along the length of this in the cross section direction, in the depth, in the diameter direction of this cylinder, it will be splitting perpendicular to which it will be splitting which one this in this direction horizontally. That vertical load is applied, it is splitting horizontally. The splitting will be because of this indirect tension, right? So this is split tensile strength they have calculated like that, right? Various trials they have done actually. Okay, so what is that split tensile strength, right? How can you get that? If you just observe, how can you get that split tensile strength, right? So F concrete, right? FCT. What is the symbol we are giving? So strength of concrete in tension, na? Yes or no? What is the FCT you are getting? 2 times that P, whatever the load P are applying, na, divided by this pi dl. Okay, L is the length. So what is that P we know? What is that D diameter we know? And what is that L length we know? Yes, no? Is it clear of you now? So what is the P? That is P is the maximum load applied at this failure or not? P is the maximum load at failure, na? Maximum load at this failure, you can say, if you just observe, right? Is it clear everyone? Maximum load at the failure, right? Now as per this IS 486, right, what is this relation between these two? Tell me. Direct tension we don't go for, bending tension, rupture strength we are having, right? So what is it you can say? That FCT will be having approximately equal to which one? 2/3 of this FCR. What is the FCR you can say? FCR is nothing but your rupture strength. You call it as this rupture strength, or you can also call it as which one? Modulus of rupture, na? You call it as this rupture strength or modulus of rupture. modulus of rupture, or you can also call it as which one? This is bending tensile test, na? Or bending tensile strength, you can say bending tensile strength, right? So now tell me which one is higher, obviously split tensile strength will be higher, or this modulus of rupture will be higher. Tell me all of you, split tensile strength will be higher, or this modulus of rupture will be higher, everyone, all of you? Which one will be higher, that modulus of rupture or this rupture strength will be higher? No, obviously modulus of rupture or this rupture strength will be higher, obviously, right? Rupture strength will be higher, obviously, you can say, right? So is it clear, everyone? Once clear, note, and once noted, tell me all of you will try to move forward. Noted, everyone? Clear? Clear? This is clear, everyone, all of you? Regarding that compressive strength and this tensile strength, regarding that compressive strength as well as this tensile strength, that everyone is clear? Is it clear, all of you? Right. So now we'll be moving on to which one? This so this is which one? This first point of note, you can say. Second point of note. Tell me, when you compare all these strengths, right, which strengths will be higher and this which strengths will be lesser? Tell me, all of you. If you are comparing, right, if you are comparing this, right, which strengths will be higher or which strengths will be lesser? If you just observe, all of you, which strength will be higher, right? FCR will be higher, right? FCR will be higher, obviously, right? FCR will be higher, obviously, right? FCR will be higher than which one? This FCT, right? FCR will be higher than which one? This FCT, right? Then FCK will be higher, very much higher than all, na? That FCK will be higher than which one? FCK will be higher than FCK cube will be higher than which one? This FCK cylinder, na? Okay, we don't write that. FCK of this cube will be higher than which one? This FCR. So that FCR will be higher than which one? This FCT. Yes, na? FCT, and FCT will be higher than which one? This F direct tension, na? FCT direct, na? Concrete in tension, that direct or not? Okay, FDT you can say, right? FDT you can write it as DT. We'll give the symbol DT. FDT is the symbol we'll give. So, is it clear now, everyone? When you are comparing this, which one? This is a characteristic compressive strength, right? When you are comparing this characteristic compressive strength, and which one? You are comparing this characteristic compressive strength and which one? That a rupture strength, and this is split tensile strength, and this is direct tensile strength, right? Is it clear, everyone? Is it clear, everyone? Right? So this is the story of your which one? This is strength of concrete, right? Next, what else will be having? This one, elastic deformation. The modulus of elasticity is primarily influenced by which one? Elastic properties of this aggregate, and to a lesser extent by the conditions of this curing and age of this concrete, right? So what are the factors affecting? Influenced by this first one, elastic properties of this concrete, that is majorly. Next one, second one, condition of this curing, and the third one is age of this concrete, right? The mixed proportions and the type of cement also, right? So what is it you can say? Age of the concrete, comma, the mixed proportions, and which one is the type of this cement, right? These are all the factors influencing the modulus of elasticity of this concrete, na? Isn't it? Which one? Elastic properties of aggregates, condition of this curing, age of this concrete, mixed proportion, and the type of this cement used, right? So how it is given? Epsilon C, that EC modulus of elasticity, short term static modulus of elasticity is 5000 root FCK as per which one? This is a new code. And what is that as per old code? If you just observe, this is short term elastic modulus, that is a 5700 root FCK as per this 1978 code, na? Everyone, IS 456 2000, a new code means IS 456 which one? IS 456 2000. And this is as per which one? This is old code, right? Very old code, right? Very old code means that what is it, you can say? IS 456, which one? 1978, you know, like that. Got it? So we'll stop with this. After that, mostly tomorrow these portions will end. Okay, these portions may mostly end tomorrow. Okay, note it and tell me. I'll close the session and get ready for 10 a.m. class. Clear, everyone? Anyone having any doubts? Anyone having any doubts in this till now? If no doubts, I'll close the session. If doubts are there, you just ask me. I'll clear. Shall I close? Those who are not in our free classes group, now you just join this free class group. Plus students, no need to join in any group. Already you are there in the plus group now. You'll be getting the information definitely whatever it is required for you. Okay. Joined. Okay. Done, everyone? Shall I close? Okay. Note it and tell me. I'll close after that. Note and tell me. Main properties are elastic property of aggregates, conditions of curing, age of concrete, mixed proportions, and type of cement. These are the factors influencing modulus of elasticity of concrete, you can see. But majorly, which one is influencing? That elastic property of aggregates. Aggregates will decide mainly, you can say, you can understand from that. So that EC will be getting in which units? That is in MPa or Newton per millimeter square. That FC also you have to substitute in which one? This MPa only. Done? Shruti, done? Yeah, you do it later because it is getting late for the other class now. So I have to make that PPT again and I have to get ready for that now. Okay. Thank you all of you. Have a good day. Thank you. Tomorrow again at 8:30 a.m. same class. 10 a.m. Nick will be having the GATE and ESC PYQs class. Okay. Thank you.